Hello. Welcome to physics. Today we are discussed about the projectile motions. Projectile motion is a most important part of the physics and also for the JEE exam and also the NEET exam. Let us start the projectile motions one by one. Projectile motions. Projectile motion is a best example of 2D motion. 2D motion means two dimensional motions. Suppose that this is a coordinate systems mean x and y. This is a y axis and this is a x axis, and this is a boy, and boy throw a ball as like this. In the situations, the path of the ball is a example of the projectile path, and the motion of the ball is a best example of the projectile motions. Suppose that boy throw ball with velocity of u, and this is a horizontal directions, angle theta, and this is a vertical, and using component of the projectile velocity along this mean ux and along this mean uy, vertical component and a horizontal component of the projectile velocity mean ux equal to u cos theta and uy equal to u sin theta. This is a variable and this is a constant. Mean horizontal component of the projectile velocity is always remain constant, but vertical component continue change with time, and at a peak point vertical value of the projectile component is 0 and only horizontal mean Vx equal to V cos theta or u cos theta, and at this point angle theta u cos theta horizontal and vertical u sin theta, and u sin theta is a negative component. This is a best examples of the projectile motions and the projectile velocity. This is a point A and this is a point B. Projectile velocity at point A mean u a equal to u cos theta I cap plus u sin theta j cap, but projectile velocity at point B u b equal to u cos theta I cap minus u sin theta j cap, because vertical component act along the negative directions, vertical downward. This is a component of the projectile velocity, and horizontal component of projectile velocity is always remain constant. But vertical component of projectile velocity is variable, and at peak point of projectile path is equal to 0, right. This is a basic concept, and horizontal directions acceleration equal to 0, vertical directions acceleration negative g because downward directions. And next topic about this, if we want to calculate projectile velocity after some time as like this, right. This is a projectile path, and in this point projectile velocity u, angle theta, ux equal to u cos theta, and uy equal to u sin theta, correct. This is a x axis and this is a y axis. If we want to calculate the value of projectile velocity at this point, right, here t equal to 0, here t equal t, and is this point projectile velocity v y and v x, angle theta, as like this, projectile velocity vector v, right, vector v. Initially horizontal component of the projectile velocity v x, using first equation of motions v equal to u plus a t, convert along the horizontal directions, v x equal to u x plus a x multiply t, and from the previous knowledge a x equal to 0 and v x equal to u x mean u cos theta. This is a horizontal component of the projectile velocity after t time, here t equal t, right, and vertical component from first equation of motions, first equation v equal to u plus a t, and convert along the vertical directions, y axis v y equal to u y plus a y t, and using the value v y equal to u sin theta minus g t, because a y equal to negative g, because gravity always act vertical downward directions, and this is a value of horizontal and vertical component of the projectile velocity after t time. And if we want to calculate total projectile velocity, mean vector v equal to v x I cap plus v y j cap, mean vector v equal to u cos theta I cap plus u sin theta minus g t j cap. This is a value of the projectile velocity after t time from the projections. And if we want to calculate this angle, and for this angle suppose that theta dash, because this is a theta, and theta dash equal to v y divided by v x, tan theta dash equal to v mean u sin theta minus g t divided by u cos theta, and theta dash equal to tan inverse u sin theta minus g t divided by u cos theta. This is a angle of projections after t time from the projections, theta dash and here theta, initial angle theta. This is a basic concept of the projectile velocity and also component. Here we can use the momentum conservation law and energy conservation law for the JEE exam, using the momentum conservation law and energy conservation law. If suppose that according to questions for the calculation projectile velocity at this point, at this point, at this point, then suppose that this is a point and B point and C point. From momentum conservation law, mean total momentum is remain constant, mean momentum at point A equal to momentum at point B equal to momentum at point C, and momentum equal to mass multiply velocity, and here include both velocity horizontal and vertical, mean Vx and Vy, both velocity include here, right. This is a basic concept, and also using the energy conservation law. Energy conservation law. Energy conservation law mean total energy at point A equal to total energy at point B and total energy at point C, mean kinetic energy, right, and potential energy, right. Kinetic energy K equal to half mv square and potential energy equal to mgh, m mass, g gravity, and at height from the ground. From the energy conservation law, mean total energy at point A, mean kinetic energy, and potential energy at point A equal to total energy, mean potential energy at point B plus kinetic energy at point B equal to potential energy at point C plus kinetic energy at point C, mean this value is always remains same, equal to each other, because total energy of the system is always remain constant. If kinetic energy increase with time, then potential energy also decrease with time, the same rate, because kinetic and potential, sum of kinetic energy and potential energy is remain constant from the energy conservation law. Next topic, flight of time, horizontal range, and some other examples. Basic concept, flight of time. Flight of time t equal to u sin theta divided by g. This is an angle, horizontal component, and also vertical component from previous explanations, and Vx equal to ux and Vy equal to 0, right. This is a flight of time, and horizontal range r equal to u square sin 2 theta divided by g, and height of projections, this is a height of projections, mean u square sin square theta divided by 2g. This is a best examples of the projectile velocity, and equation of mean coordinate of the projectile particle. Suppose that this is a projectile path, and here coordinate 0 0, here coordinate r and 0, here r by 2 and h, because this is a h, right. If we want to calculate the coordinate at this point x and y, right, x and y coordinate after t time, using the second equation of motion for the very simple explanations. Second equation of motion, s equal to ut plus 1 by 2 at square, x equal to uxt plus 1 by 2 axt square for the x directions, and ax equal to 0, and this term become equal to 0, and x equal to u cos theta multiply t, mean t equal to x divided by u cos theta. This is a time, right, this is a t time, and vertical component mean vertical coordinate, using second equation of motions, s equal to ut plus 1 by 2 at squares, convert along the y directions. This equations mean y equal to uyt plus 1 by 2 ayt squares, using the criteria of the value, mean ay equal to -g and uy equal to u sin theta mean y equal to u sin theta and x divided by u cos theta minus 1 by 2 g and t square, and value of t put here, this value, and finally calculations mean x tan theta minus g x square divided by 2 u square cos square theta. This is a value of the y coordinate after t time, right. And next relation between y, x and r. What is the best relation between them and most important for the JEE mains exam, right. This formula using y equal to x sin theta divided by cos theta minus x square divided by 2 u square cos square theta divided by g, right. And common factor x divided by cos theta and sin theta here is a remaining part minus x divided by 2 u square cos theta divided by g, and equation of projectile range r equal to u square sin 2 theta divided by g and u square 2 sin theta multiply cos theta using identity of sin 2 theta divided by g, and here r divided by sin theta equal u square 2 u square cos theta divided by g, and 2 u square cos theta divided by g using this identity, right here, right, mean y equal to x divided by cos theta multiply sin theta minus x divided by r divided by sin theta and y equal to, after calculation of this equations, x tan theta, right, x tan theta 1 minus x divided by r. This is a common relations between x, y and r coordinate. And next topic for the explanations, radius of curvature, and radius of curvature is a most important part for the JEE exams, radius of curvatures, and every point of the projectile path along the circular path, radius of curvature. Right, r. Suppose that this is a coordinate systems, x axis and y axis, and this is a projectile path, right. This is a projectile path and projectile velocity u along this u x and u y similar, and suppose that particle point at point A moving at point A as like this and velocity v, right, and this is a projectile, this is a radius of curvatures, radius r, and mass of the ball, mass of the object act along this directions mg, weight of the ball mg, and this is a angle. Suppose that this is a angle, alpha, right, and respect to angle component of the weight mean mg cos alpha, and here mg sin alpha, and for the circular motions centrifugal force act vertical just opposite direction to the center of the circle, mean mv square divided by r, right. And using here FBD as like this, here mg cos alpha and here mv square divided by r, both are equal to each other, mean mv square divided by r equal to mg cos alpha, and m cancel out to each other, v square divided by r equal to g cos alpha, and using centripetal accelerations v square divided by r, and r equal to v square divided by g cos alpha, and v is a vertical and a horizontal, both value include here horizontal and vertical, right. This is a concept of the radius of curvature. And projectile velocity and projectile motion in uniform electric field. Projectile velocity, motion in uniform electric field. This is a most important topic for the JEE Advanced exam. Right? JEE Advanced exam. Suppose that this is a uniform electric field, and direction of electric field vertical downward, and this is a charge plate, uniformly charged, right, negative charge, right, and uniform electric field E, vertical downward directions, and charged particles project in a uniform electric field. Suppose that positively charged particles plus q charge projectiles as like this. In the situations, calculate flight of time, range, and all parameters of the projectile motions. This is a horizontal range, and this is a horizontal range. This is a horizontal range, and here initially we are calculate the accelerations, mean effective accelerations, mean accelerations due to electric field vertical downward, because this is a positive charge and this is a negative, and downward directions act electrical force and divide by mass is a electrical accelerations, and gravity also act vertical downward directions, mean G effective equal to G plus QE divided by M. If for your confusions, capital Q using here charge capital Q and here capital Q, mean G effective equal to G plus capital Q E divided by M. This is a value of G effective, right, and for the calculations AY equal to minus G effective, right, and using the same formula, right, for examples flight of time t equal to u sin theta divided by G, not using only G, G effective, and flight of time t equal to u sin theta divided by G effective, mean G plus QE divided by M, right. This is a result for your most important for the exams, and for the range of projections, mean u square sin 2 theta divided by G, not only G, G effective, and value of G effective equal this, right, and the range equal to u square sin 2 theta divided by G plus QE divided by M, and height of projections h equal to u square sin square theta divided by 2 g, not g, g effective, and the value of g effective equal to g plus q e divided by m. This is a value of height, range and flight of time in uniform electric field, and some other basic criteria of the projectile motions with related to uniform electric field. Suppose that electric field act vertical upward directions, right, and a negative charge particle, positive charge particle project in a uniform electric field. In the situations, gravity act vertical downward, and accelerations mean electrical force act vertical upward, because this is a positive and this is a negative, right, mean q e divided by m. In the situations, g effective equal to g minus q e divided by m, right. Using the same concept for the calculation of the projectile range, height and equations, and also velocity of the projectiles. This is a basic concept of the projectiles velocity